Namaskar and welcome to the session on water in food. This session is for the students enrolled for the Food Safety and Quality Management program. We all know the importance of water. It is one of the wonderful gifts given by the nature to the humankind. The water has many unique characteristics. The objective of this session is to have an awareness and appreciation about this unique characteristics of water. The structure of the presentation is to cover the structure of the water, its property, then its role, particularly in the food processing, and what should be the water quality in a food processing unit. The uniqueness of the water is because of its structure. So, we will start with the structure of the water. The water, as we know, it is known as H2O. You must be remembering in your school level also. So, the molecular composition, the H2O, consists of 2 hydrogen atoms and 1 oxygen atom, as shown in the slide is there. Now, the bond between the hydrogen, oxygen and hydrogen, this bond is slightly bent. Why it is bent? Because this is approximately of smaller to the value of 104.5 as against the normal value of 109.5, and this creates a bent shape, and this leads to the polarity into the molecule, and this is also one of the reasons for the very unique characteristics of the water is there. So, when we say the polarity is there, it has a positive charge on the hydrogen atoms and a negative charge on the oxygen atom is there. The electron density is found more on the negative part of the molecule is there. This leads to hydrogen bonding, and this hydrogen bonding is the responsible for the unique properties to the water, which we will be discussing shortly. Within the water molecule, it has a covalent bond as shown in the picture, and it has a weak hydrogen bond. But the number of hydrogen bonds are more, so that it gives the unique characteristics which we will be sharing. The water has a relatively smaller molecular size, and because of this also it has a unique physical properties. Like one of the examples is it remains in liquid format room temperature because of the intermolecular forces also. Now, what are the properties? If you see, the water has the boiling point of 100, freezing point of 0 degree centigrade, and this is a very high value is there as compared to the same molecular structure is there because of the hydrogen bond. Large number of hydrogen bonds are present into the system. This has also the high specific heat is there. Now, that is, we know about the specific heat, and this is indirectly type of a heat capacity is there. This is helpful in food processing for the temperature regulation. It gives us that it absorbs and releases large amount of heat with little temperature change is taking place. Now, this becomes important when we are processing any food product which contains the high water content is there. So, this is one of the point which you have to take care, that if the water will be high, it will have a different processing time and different effect will be there. It has also the density also, the maximum density is at 1 at 4 degrees centigrade, and it expands upon the freezing, and it makes ice less dense than the liquid water. And that is why this is an example which we see in our aquatic life also. The aquatic animals are able to float properly on the layer of the ice under the water, so they can properly float is there. This also has a high surface tension is there, and The more important property is what we call as the wonderful liquid. It is because of the universal solvent. It is a universal solvent, and this is because of the high polarity. It makes it an excellent solvent is there. The thermal conductivity is also very high, and it is effective in heat transfer, and we use this also in many of the processes is there. Similarly, there is a good cohesion force because of the hydrogen bonding, and similarly there is a addition is also good. That's why you can see that the water sticks to the other surfaces is there. It also exhibits the capillary action, that it can flow into the narrow spaces, and which is essential for particularly plant nutrient transport is there. The dielectric constant is also very high, and it is used in the sensors, in the development of design of the sensors. This property is used. Similarly, this has the high heat of vaporization is there, and also it has a supercooling effect, that we can cool the water up to -40 to -50 degrees centigrade, and this ability is used in the food preservation is there. So these are the certain characteristics of water, and this is because of its polarity, its hydrogen bonding, and its the structure of the water. These are the aspects which is there. Now we come to the water in food. That is, the food contains water. Certain products contain high amount of water, like fruits, vegetables, meat. They contain in very high range of the water. It is 70 to 95%. Similarly, the products which contain the moderate moisture, that is 30 to 70%, they are like the baked goods, cooked grains, they have the moderate moisture content. And with the low moisture content, we have the particularly like the dry fruits are there, grains are there, so they have the less. And very low moisture is the powders, spices, they have a water content of less than 10%. Now, this moisture percentage has the impact on the quality, particularly texture, shelf life, and quality of the product is there. Now, this relation of the moisture, particularly with the temperature and the vapor pressure, is also in one way classifies the hygroscopic and non-hygroscopic product is there. So, the products on which depends on the temperature and partial vapor, they are linked with the hygroscopic, and non-hygroscopic do not get affected by the temperature and partial vapor pressure. Now, to give you example that how much water is there in the percentage is given, like the green leaves, it contains 95%, tomato is also having 95%, potato is having 78%, and then the rice is having 12%, the legumes 9 to 11%. Because of this only, the legumes, rice with low water percentage has a longer shelf life. Similarly, within the fruits and vegetables, the green leaves, they shrink and die because of the 95% moisture which is there. So they spoilage is there. Potato has a longer shelf life. So the water percentage also have the effect on the shelf life of the product is there. Now, how do we see the water? Water is present in two forms. One is in the free water, and second is in the bound water is there. When we say the free water, it is not chemically bound to food components, and it's available for the microbial growth and chemical reactions is there. The bound water it is bound to the food components like protein, carbohydrate, and this also gives the shape to the product. This is also one of the advantage that bound water, it gives the structure to the proteins, carbohydrates, and the shape is there. Now, this bound water and the free water, it has impact on the quality or the shelf life of the product is there. So, the food stability, the bound water gives the stability and shelf life the product, because it is less available for microbial growth is there. And how do we estimate this? There are different methods are there, like Simple method is the by drying method. Similarly, by chemical method is Carl-Fish titration is there, and by spectroscopic also we can estimate the free water and the bound water in the present there. So the moisture content we say what it is. It is the total amount of water present in a food, and it is expressed as the food percentage of the total weight is there. Like when we say that in the last slide we saw the moisture is 11%. So total weight, that is in the constituent, the water will be around 11% is there. Now its importance is it affects the texture, flavor and shelf life of the product is there. Method we have explained already, that is we can estimate by the gravimetric method or drying method, then Carl-Fisher method is there. So these are the methods are there. Now they are important for we can control the moisture content during the processing and storage. The minimum the moisture, it is better. But then if high moisture can lead to the spoilage, while low moisture can cause the textural changes are also there. So this is the importance of moisture into the food is there. Water activity is the ratio of vapor pressure of water in a food to the vapor pressure of pure water at the same temperature. It signifies the availability of water for microbial growth and chemical reactions. And this has an impact on food stability and safety. The methods how to estimate are hygrometer, dew point method, chilled mirror method, and water activity meters are there. As I mentioned, they are responsible for the microbial growth and chemical reactions. And normally, if we lower the water activity, it inhibits the growth of bacteria, yeast, and mold, and extend the shelf life of food products. Is there? Then, how do we control? Basically, we can control the water activity by methods like drying, freezing, or adding solutes like salt and sugar. Now, let us see what is the water activity in some of the common products. Like it is range from 0.00 to 1. So, it ranges from 0.0 bone dry, that is, and 1 for the pure water is there. And in food product, it ranges from 0.2 for very dry foods to 0.99 for moist fresh products. Like fruits and vegetables or perishable vegetables, the water activity is 0.95. And on the other end of the spectrum, like noodles, it is 0.5 is there. Similarly, for the jams, it is 0.75 because it contains the sugar. And the dried fruits, it is 0.65 is there. So this will give you an idea that what is the water activity and what is the shelf life. So we have covered up till now the importance of water, that is, it sustains the life. It is one of the wonder liquid or with a lot of unique characteristics. The molecular formula is H2O, and water molecule is a bent molecule with a bond angle of 104.5. It is a polar molecule with greater electronegative density near oxygen atom, and the hydrogen bonding among molecules leads to many unique properties, and the unique properties include like universal solvent, high melting point, boiling point, specific heat, dielectric constant, thermal conductivity and supercooling. So these are the characteristics. Now we come to the sorption isotherms. So we studied the two parts, moisture and the water activity. Now these sorption isotherms are graphs which gives us the relationship between the water content and the water activity at a constant temperature. Now what is the purpose? It helps to predict how food will interact with the moisture during storage and processing. There are two types of curves are there, absorption isotherms, that is moisture uptake, and the desorption isotherms, that is the moisture loss is there. The purpose is that it helps in preservation, drying, packaging and storage for optimization of processes and to ensure the product stability is there. There is another term hysteresis That is the difference between the adsorption and desorption isotherm, which you'll see in the next slide, we will show you. So, this is a typical sorption isotherm is there. We have a water activity, then we have a moisture percentage. So, you can see in this graph. So, there is an adsorption, desorption is there. Then there are different region is there, region 1, region 2, region 3 is there, which are being explained in the subsequent slide is there. So, there is a region 1 is monolayer formation is there. Similarly, region 2 is there, where lot of moisture absorption will take place. Similarly, region 3 is there. So, let us see that how we estimate how we draw the chart, sorption isotherms are there. So, this is a basically, normally when we say that the high moisture content, it will have a larger water activity. But this relationship is not linear. It shows a sigmoid curve is there, and this is with at given temperature, it is called the moisture sorption isotherm. Then how do we draw this curve? When what we do, we take that dry food sample and keep it in atmosphere of increasing relative humidity is there. The increase in weight is noted due to absorption of water, and this is plotted to get the sorption isotherm is there. So, this is a plot of water absorbed, that is moisture content, as a function of relative humidity or water activity is there. Now, there are three regions you saw. Region 1, it is a initial increase in moisture content and formation of monolayer film on the absorption of the food constant. This is very important. This gives us the shelf life of the product indirectly, that what is the safe moisture for a higher shelf life. Region 2 is the absorption of additional layer of water over the monolayer is there. And in region 3, there is a condensation of water in the pores of food material that dissolves the soluble components of the food. So, monolayer moisture value is calculated, and this helps to determine the shelf life of the product is there. Similarly, desorption isotherm. So, what we do is, it is a reverse of thing. In this, the wet samples is placed in the atmosphere of relative humidity, and then decrease in weight is noted, and then data is obtained. And the difference between the desorption and absorption is called the hysteresis, and generally observed in most of the hygroscopic products which we explained to you. Now, what is the application of these term, this sorption isotherm? They are mainly for the food preservation, that to predict the shelf life and stability of food product by understanding the moisture relationship, and also helps in designing the packaging material and moisture control is there. It also plans in the optimization of drying and dehydration process, and in the quality control activities, that how we can maintain the product quality, or in the new product development also, that how much should be the moisture content and water activity should be kept into the product. This also comes to the next step. We said that the water activity is related, that if you have a high water activity, the food will be easily spoiled. So, now what type of food spoilage can take place? We all know that naturally food will have a limited shelf life. It starts with the food decay, then food spoilage, and ultimately it is not fit for consumption. So, spoilage is when the food is not eatable or it is hazardous to eat is there. One is a natural way, because there is a loss of moisture because of respiration, and the enzymes will be acting on it. The other thing is the microorganisms, bacteria, yeast and mold, they grow, and other constituents like proteins, it will get putrefied and give the false smell. Fats and oil will get rancid, it will give the smell and bad taste there. The cooked cereals, particularly rice, so they contains carbohydrates, they become marshy and they are called stale is there. So, this is the food spoilage is there. Now, we will classify on the basis of the moisture and on the water activity. So, if the low moisture foods are there, like in the range of 5 to 15% dried and the freeze dried, so they have a longer shelf life. Intermediate moisture foods, like with the 20 to 40%, like cakes, dates. So you have some shelf life is there better than the low moisture. And high moisture food which are having the moisture more than 40%. So like fresh fruits and vegetables, and they are easily spoilables are there. Now you can see the link between the water activity and the shelf life. If the water activity is 0.2 to 0.3, the monolayer is formed. If you saw in the soft isotherm, the first region monolayer is formed. It represents the optimal moisture content for the maximum shelf life of the dehydrated food is there. 0.35 to 0.45, when the particularly more water is added. So this causes change in the physical state like loss of crispiness, stickiness and dehydration is there. And in 0.4 to 0.5, like soft material like raisins will become hard due to drying out is there. Now 0.6 water activity is very critical because there is a potential for growth of microorganisms if the moisture content increases. Now 0.6 to 0.8, where the chemical reaction required an aqueous phase and cause deterioration of food reaching a maximum will be there. The another critical point is 0.85, where the bacterial spoilage will take place and the growth of pathogens will take place is there. So we can say the water in food spoilage, that is microbial growth, high water activity will promote the growth of microorganisms and spoil the product, and also can give the foodborne illnesses is there. Similarly, enzymatic reactions can also take place. Enzymes will cause the spoilage. Chemical reactions, water can participate in the chemical reaction such as oxidation and Maillard burning. It can also bring the physical changes like moisture loss or grain can lead to spoilage is there. So what are the control strategies? Particularly proper processing, packaging and storage should be done. And monitoring, regular check the water activity and moisture content. We should check the moisture content regularly of the product which are properly stored is there. So the objective should be that if we want to control the food spoilage, we have to lower the water activity. And how we can control it? By drying, by freezing, by sugar or salt. Actually, what happens when we add salt or sugar to something, it will control the free water. It will not be available and it will make it bound. Similarly, in drying also, it lowers the water activity. And lowering the temperature during freezing, check the activities of enzymes and growth of microorganisms will take place. So now in this part, what we have covered, what is the relationship between the water activity and moisture, the soft cell isotherms, what is their importance, that is there are two types, adsorption isotherms, then desorption isotherms are there. And these help to predict the shelf life and the stability of food product is there. We also learned about the food spoilage is there, that the food becomes not eatable quality or hazardous to eat is there. And it has a, water activity has a relationship with shelf life, and like 0.2 to 0.3 is the first which gives us it will have a longer shelf life and what the moisture percentage we can keep. 0.6 where the growth of microorganisms can take place. 0.85 where the growth of the pathogens can take place. And 0.3 to 0.4 where the crispiness of the product is lost. Now we will quickly refresh the role of water in human health. As we know, water makes approximately 60% of the adult's body weight, and it's very essential for life because of the many reasons, like it supports the cellular functions, many biochemical reactions, the fluid balance, and also the hydration to the all of us. It is involved in nutrient transport, waste removal, temperature regulation, joint lubrication, and the cell structure and function. These are the functions which are undertaken by water, and we studied also in the first of our presentations. What the physiological function it covers is a particular like nutrient transport takes place, that is water in plasma transports nutrients, oxygen, hormones, and removes the waste product. Regulate the temperature through sweating, respiration, preventing overheating. Waste elimination in the formation of urine is there. Joint lubrication. Similarly, it helps in the digestion process and maintains the cell structure and biochemical reaction. So these are the activities which it performs. And it is very essential that we should take minimum 2 liters of water per day, and it benefits particularly like our physical performance is improved, digestion is improved, our skin health is also very look very hydrated, elasticity, kidney functions are better, and weight management it also help if you can drink water before meals, it control appetite and reduce calorie intake is there. Similarly, the functioning of mind is also better if you are well hydrated is there. Now, we'll come more on the role of water in food preservation. We said there are methods which are involved, like a drying method is there, that we remove the water and it inhibits the microbial growth and prolongs the shelf life like dry product. Similarly, frozen products are there where the water is frozen, like if you've seen the frozen peas, they have a longer shelf life, microbial growth is less, and the zymatic activities are minimum. Similarly, canning examples, you have seen the canned soups or vegetables, products are heat treated and all microbes are killed. Salting and sulfuring, we have given the example of like jams, cured meat, salted fish, so they have a longer shelf life. Similarly, fermentation, if we can control the water activity and create an acidic environment, like so it will have a more shelf life is there. So these are the ways how we can, the role of water in food preservation can take place. Now, water in food processing, it is in the product formulation. Normally, water is an ingredient in many of the product. The next is cleaning and sanitization. It is used to clean and sanitize the raw material, equipment, all the facilities, and which is essential for hygiene and safety. The blanching, particularly the vegetables are blanched to inactivate the enzymes and preserve the color. The next is cooking and boiling. It is essential for cooking processing such as boiling, steaming and simmering, and which affect the texture and flavor of the food is there. Then the water in food processing also involves the mixing and dissolving, that you want to dissolve of any of the ingredients, so to make suspension it is used. Heat transfer, it is a good medium for the transfer of heat, particularly in pasteurization and sterilization. And in utilities also, like steam production, chilled water and waste disposal and effluent treatment. So if these are the roles of the food processing of the water is into there. So, and the purpose is basically to control the moisture, and similarly in the packaging also the minimum moisture contamination should take place, and we can have the nowadays the smart packaging or modified atmosphere storage is there. During the inventory management, it is important that we monitor the storage conditions and rotate the product to ensure the food safety and quality is there. Is have an impact on texture also, like a crispiness, tenderness and firmness of the product is very much dependent on the moisture percentage. Similarly, it has the other values like gelling of thing, viscosity, mouthfeel characteristics. They all are related with the water's presence of water. On the flavor also, it's a good solvent for the flavors. It is also involved in the release of the flavors. The dilution effect is also there. Then it can bind also the flavor components and the release at appropriate time is there. So these are the water's impact on the flavor is there. So we have now in this part, we have seen that the water has a major role in our health is there, and it's very important that we should take the adequate amount of water to improve our physical performance, mental performance, and the digestion also is there. The methods are for the preservation includes control of water, like particularly drying, freezing, salting, sugar and fermentation. And in various processing where it is involved, it is in the new product development or product, it is an essential component. So product formulation, cleaning and sanitization, cooking and boiling, blanching, and these are the things which we can, uh, where they plays an important role, and it also has impact on texture and sensory properties are there. Now we come to the what are the physico-chemical parameters of water quality, because we have said that the water plays an important role. So then let us come for the physico-chemical parameters. Like first thing is the pH is there. It should range from 6.5 to 8.5 per potable water. If it is too acidic, it is also not good. If it is too alkali, it is also not good for our processing is there. Similarly, turbidity is the clarity of water is there. So it indicates the presence of suspended particles. So when we use in food processing, it can affect our product is there, appearance, suitability. The conductivity, it is the ability of water to conduct electricity, and the presence of dissolved salt will be there. So it is an indirect, it is a parameter to judge the water quality is there. Similarly, the color, odor, taste, it should be agreeable, should be there. Total dissolved solid is a concentration of dissolved substance in water, including minerals, salt, and organic matter. You must have heard the term hardness. It is a determination of concentration of calcium and magnesium oils, and hard water can affect the cleaning efficiency and the equipment performance is there. Alkalinity is the ability to neutralize acid and maintain stable pH level in food processing. So these are the important physiochemical properties. Now hardness of water is very important. As you know also, it is because of the chloride, carbonates, bicarbonates of the calcium and magnesium, and temporary hardness is because of the bicarbonates of calcium and magnesium, and permanent hardness is sulfate and chlorides of calcium and magnesium. Now it is normally expressed in the concentration of calcium carbonate in ppm units is there. Soft water, if it is less than 50, it is very good. Normally up to 75 is the limit. Medium soft is 75 to 150, and very hard is 150 to 300. On boiling the water, the soluble carbonates converted into insoluble carbonates, and the temporary hard water gets softened. But then this cannot remove the permanent hardness of the water. Boiling is there, but there is a formation of scales will be there. The precipitate carbonates will form the scales, and there can be clogging can take place. Now when we cook to the food items in hard water, so there can be changing textural properties. Calcium may form the calcium pectate, which can give the firmness to the product. But then higher amount of calcium may make some food tough also. So these are the point. Now we come to the microbiological quality. So microbiological contamination should be minimum. That is, the bacteria, virus should not be there. Similarly, coliform should be is an indicator of the contamination or potential presence of pathogens. That should be also minimum. And one of the E. coli is a term, is a coliform bacteria that indicates the fecal contamination and significant health risk is there. It should not be, coliform count should not be more than 50 mpn, or in our ISA standard it is 0 mpn has been given. Then similarly, the formation of biofilm and the legionella is there. So their presence of biofilms can harbor harmful microorganisms and affect the water quality. And we can test by the culturing techniques are there to check the quality of this. These are the standards. Normally for our food processing system, the water quality should be IS 10500 standard is there. But the standards are also given by ICMR, WHO, and the Central Public Health and Environmental Engineering Organizations is there. So these are the standard for the ISO 10500. pH should be 6.5 to 8.5. Total carbon hydrogens should be 500. Calcium should be 75. Total coliform count should be nil per 100 ml should be there. This has an effect on the particularly flavor and taste, texture, shelf life. The poor water quality will give the poor product will be there. Now, also have a impact on safety, nutrition value, and compliance will be also impacted by this. Nowadays, lot of when the FFSI inspection or audit is there, the water quality is given, is one of the important components which is checked. Now, how we can control the water quality in our food processing system is there. Make it as a critical control point. So when we say that as a critical control point, monitoring will be there. We can also do the risk assessment, that what are the potential hazard related to water quality and how we can prevent it. It is there. Then we can keep the monitoring procedures, regular testing of water quality, and we can take the corrective action, and record keeping should be undertaken properly under the HACCP. Now, how we can ensure that compliance with the water quality? It is through the regular testing and training to the people who are involved in the water testing is there. Proper documentation should be maintained. Audit should be also done, internal and external, to see that we are complying to the water quality standards or not. And what are the best practices for water quality management? First is the source protection should take place. Ensure that the water is from it is protected from the contamination. And the treatment processes like effective water treatment, like filtration, chlorination, and UV treatment should be there. Sanitation practices should be there. And we can also install the automated monitoring system to track the water quality measures should be there. Now, what are the future trends is there? The advanced filtration technologies, smart monitoring, sustainability is very important, and particularly use of water, and reducing the water waste in the food processing is there. And lot of research should be there in the own plant, that how we can improve the water quality management practices there. So, in a summarize, that water is essential for all forms of life, and it is called a wonder liquid. And this, the unique characteristics is because of its structure. It's a bent shape bond angle, and there is a polar molecule is there. It is relatively small molecular size, and lot of hydrogen bondings take place is there. Then the microbial and the chemical stability is directly related to the water activity is there. Water quality should be as per our ISI standard, ISI 105000. And also remember, the World Water Day falls on 2nd March, and this year theme was Water for Peace. So thank you very much. Thank you.